Hello students, welcome to the video lecture 1 from module 2. It is topic work and heat by Professor Prashant S. Shedbalkar, Mechanical Engineering Department, VSM's SRKIT Nippani. Just we'll start with the introduction of work and heat. So first we'll study what do you mean by heat and how heat will transfer, then we'll come for the work. So this is the sketch you have shown here. Just consider this is a closed system in which mass is kept constant. You can see here energy, it is in the form of heat and work. These are the two forms of energy. This energy in the form of heat and work, it is crossing the boundary of a closed system. I can give you an example for heat transfer. A cold drink can, which is kept on a table, it eventually warms up, and on the same table a cup of hot coffee is kept and it eventually cools down. You can see here. So this cold drink can and a cup of hot tea, it is kept on the same table, where this cold drink can, it eventually warms up, and a cup of hot coffee, it eventually cools down. That means when a body is left in a medium at different temperature, energy transfer takes place between a system and the surroundings until the thermal equilibrium is reached. That means both the body and the medium or surroundings, it should reach the same temperature, then only the heat transfer stops. You can see here for this cold drink can, the temperature of this cold drink can is very less than the atmospheric temperature. So this cold drink, it is my system here, and the cover of this can, including inside and outside, this becomes the boundary, and surroundings is my atmosphere, which is nothing but air. So as the temperature of this system is lesser than the temperature of the atmosphere, so heat transfer takes place from the atmosphere to this cold drink can. For that purpose, it eventually warms up. Means after some time, it gets warms up. Means both the heat will be continuously transferring until the thermal equilibrium is established. That means this temperature and atmosphere temperature, and both the temperatures are same, heat transfer stops here. So here the temperature of the tea is higher than the temperature of the atmosphere. So as we know that heat always flows from higher temperature medium to the lower temperature medium, here heat transfer takes place from this heat to this atmosphere. So after some time it gets cooled down. Cool down means, so up to what level heat is transferring here, and this the temperature of the tea as well as the temperature of the atmosphere, when both are same, their heat transfer stops. So this is nothing but the energy is transferred in the form of heat. That is, energy is crossing the boundary of the closed system in the form of heat here. So now how we will define this heat? It is defined as the form of energy that is transferred between two systems or between a system and its surroundings by a virtue of temperature difference. So already I have told you that heat always flows from higher temperature medium to the lower temperature medium. Heat is the energy in transition. It is recognized only when it crosses the boundary of a system. So when this heat is recognized, so only when it crosses the boundary of the system, then we will tell that energy is crossing the boundary of a system. That means heat is the energy in transition, which is flowing. I can give you another example. This is a hot baked potato. So let me consider this potato is our system, and the skin of the potato, it is the boundary of this system, and the air which is external to the system, it is nothing but our surroundings. So this potato, when it is baked, it contains energy, but this energy is the heat transfer only as it passes through this skin of the potato. That means boundary of this system to reach air or surroundings. So here heat, the energy transfer takes place which is in the form of heat. It is crossing the boundary of this closed system. So when it is recognized heat transfer only when it crosses the boundary of the system. So now next point we will study what do you mean by adiabatic process? A process during which there is no heat transfer, it is called as the adiabatic process. So there are two ways a system can be adiabatic. In first point, a system is well insulated. So when it is well insulated, that even though insulation we have provided, but only a negligible amount of heat is transferred through the boundary, then we will call that system as the adiabatic system when it is well insulated. That means heat is not entering the system and heat is not leaving the system when it is well insulated. So no doubt a very negligible amount of heat will be transferring, that we are neglecting it here. The second point, when both the system and the surroundings they are at the same temperature, then we are going to call it as an adiabatic system, because when both the system and the surroundings are at the same temperature, then there are no any driving force for the heat transfer. So already we know that heat always flows from high temperature medium to the low temperature medium. So already when the system and the surroundings they are already at the same temperature, then there will be no any uh, uh, difference in temperature. That means there is no any driving force for the heat to flow. So this is about the adiabatic process. And this uh, adiabatic word, it comes from the Greek word that is adiabatos. The meaning of this adiabatos means not to be passed. So in an adiabatic process, there is only work interaction between the system and the surroundings. There will be no any heat interaction, because adiabatic means the heat is not flowing from the system or heat is not entering the system. There will be only work interaction in the adiabatic process. And another one main thing, the students, you should not get confused with this adiabatic process with the isothermal process. So isothermal process means the temperature remains constant throughout the process, whereas adiabatic process means heat is neither entering the system nor leaving the system. You can see here in adiabatic process, even though there is no heat transfer, but the energy content and the temperature of the system can still be changed by other means such as work. So the meaning of adiabatic is neither heat is entering the system nor heat is leaving the system, but still the temperature or the energy content and the temperature of the system can still be changed even though there is no heat transfer, but still the energy content and its temperature can be changed by other means such as work. So when work is performed on the system, the energy content and the temperature of the system can be changed even though it is in a adiabatic condition. So next we'll write how we'll write the notations for the heat transfer. You can see here the amount of heat transferred during the process between the two states of a system, that is state 1 to state 2, is denoted by capital Q12 or just Q. Q12 means the heat is transferring from state 1 to state 2. So from state 1 to state 2 it is moving means we are going to call it as a process. So the amount of heat transferred during the process between the two states of a system, it is denoted by Q12 or just we are representing it by Q. The heat transferred per unit mass of a system, it is denoted by small q. Small q, it denotes heat transferred per unit mass. Small q meaning is same, or if you write capital Q divided by m, heat transfer per unit mass, it is denoted by small q. Its unit is kilojoules per kg. So sometimes it is desirable to know the rate of heat transfer, that is the amount of heat transfer per unit time. At what rate the heat is transferring from state 1 to state 2, that is nothing but amount of heat transfer per unit time instead of total heat transferred over some time interval. So just we can tell for 1 hour this much heat is transferred. So instead of that, so what is the rate of heat transfer? That is means the amount of heat transfer per unit time. So how it is denoted? The heat transfer rate, it is denoted by the symbol capital Q dot. So where this over dot, it stands for per unit time. If I will write Q and on that Q if I will put over dot here, it indicates per unit time, that is heat transfer per unit time. The heat transfer rate Q dot has units kilojoules per second because the second indicates heat transfer per unit time. The unit of heat is kilojoules. Heat transfer per unit time, that is joules per second, is nothing but watt, or we can write in this kilowatt also. So now we will see when the heat transfer rate, that is Q dot, it varies with time, that is from time t1 to t2. So then how we will indicate it? Then it is determined by this Q is equals to integration of t1 to t2, that is from time t1 to time t2 Q dot dt when it is varying with the time. Then it is determined by this symbol or in this form when it is varying with the time. So unit will be kilojoules. And suppose when the heat transfer rate Q dot, it remains constant during the process. So how we are writing this heat transfer rate? Q is equals to Q dot into delta T. When the heat transfer rate Q dot, when it remains constant during the process, then we are indicating it by this symbol. That is nothing but delta T is nothing but T2 minus T1, which is the time interval during the process.